Okay, so I want to show a very short video of how to construct a truth table with many inputs, right? So we have we'll say a multi-input truth table. Now we should know that truth table simply shows us all of the possible options when trying to look at a logic circuit with many different inputs. Okay, so we know that if we have two inputs A and B, we have 2 to the power of 4 possible rows in our truth table. Right, so we can say that with two inputs, well, we have 2 to the 2 rows. And we've seen a few examples of this, right? But let's consider, okay, so if we have 3 inputs, where we know that each input can be on or off, we would say that we have 2 to the 3 rows. But really the idea here is, well, how do we construct the table, right? So what I'm going to say is that the best way to do this is, right, if we consider we're going to have our inputs, let's say if we have our 3 inputs here, and our inputs are A, B, and C. Okay. Well, essentially what we're going to have is A, B, and C. Now with 2 to the 3 rows, so this is going to give us 8 rows, yeah? Okay, so let me have a look. So we're going to have 1, 2, 3, 4, 5, 6, 7, and 8. Right, so we have 8 rows, and essentially we need to know, well, how do we construct the various combinations, right? So the best way to do this, yeah, I think is, well, we look at 8 rows, right? So what we say is, well, we're going to start with the initial letter, right? So we say 8 divided by 2, this gives us 4 trues followed by 4 falses. Now we take the 4 here, and we say 4 divided by 2 gives me 2 trues followed by 2 falses. The 2, we take this down, we say 2 divided by 2 gives me true followed by a false, or 1 true followed by 1 false, yeah? So essentially what we're trying to look at here is to figure out, well, what is the pattern that we actually use, right? So we can kind of say that this represents the pattern, right, of how to complete the truth table. Okay, so let's just see what that looks like. Okay, so, well, if I was to fill this in now, so I'm starting off with the first symbol is going to be 4 trues followed by 4 falses. So I would simply say true, 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 and then 1, 2, 3, 4. The next one's going to be 1, 2, 1, 2 falses, 2 trues, followed by 2 falses. And the last one is simply going to be true, false, true, false, true, false, true, and false. So I can see what's happening here, right? So I have now all of the possible inputs from the 3, all the possible combinations of inputs from those 3 input symbols, right? So it doesn't matter, right? So the pattern is simply 4 trues followed by 4 falses. We take the number of rows divided by 2, and this shows us the pattern. So if we were to have 16 rows with 4 inputs, we would then simply have, well, okay, that's great. We would have 16 divided by 2 is equal to 8 trues followed by 8 falses. And then we would fall back into this particular pattern, right? But it's just very important to be able to say that this identifies the pattern of construction. Now, it's quite easy to construct these truth tables, but if you make a mistake, it actually prohibits how you're going to finish off describing a particular logic circuit. Because all we would do then is we add in the various expressions here. So we might have A, B, and then so on all the way down, right? And we're able to construct any number of components here, and the idea will be that we build up a full logic expression. But in this video, I really just wanted to show this very simple approach of mapping the number of inputs. Like here, we have 2 inputs. Well, 2 inputs gives us 2 to the power of 2 rows. 3 inputs gives us 2 to the power of 3 rows, which then gives us 8 possible rows, representing all of the combinations with 3 inputs going in. Okay, so now that we're done, well, we should just simply finish off by drawing a little happy face. Okay, thank you.